Let's see about the next one, which is going to be called as Handshake Protocol. What actually an Handshake Protocol is? The most complex part of an secure socket layer is nothing but Handshake Protocol. This protocol allows the server and client to authenticate each other and to negotiate an encryption and a MAC algorithm, message authentication code algorithm, and cryptographic keys to be used to protect the data sent in the SSL record. Okay, so this handshake protocol is used before any application data is going to be get transmitted. So mainly we are going to use this handshake protocol in SSL for the authentication of each other, each parties from both the end, and to negotiate the encryption algorithm. They can decide, they can discuss, and they can decide what kind of encryption can be get done over there for the data security, and they can decide the MAC algorithm and the cryptographic keys. What kind of key we are going to use, what is the length of the key, whether it's going to be in AES or DES. Based on the encryption process, key is also going to be get present over there. So these are the applications, these are the methods which I can apply over there. And for any application, before the application, any data, the application data has to be transmitted. This process has to be get understand by the both end. This is the actual handshake protocol process which is going to get present over there. The handshake protocol, which consists of a series of message exchange by the client and server, so which can be seen one by one. We will see that one. So in general, if you're going to see about that one, the handshake protocol, which may be get carried over with a particular action. I'm going to describe the action, what actually is going to be done over there. One by one I will see that one. Okay, so first it's going to show that which indicates a type as 1 byte, indicates one of 10 messages, okay, which have been defined already. We have seen the message types over there. Now such one it's going to get intimate there. And coming to the length, it's a 3 byte length. The message is going to be, the length of the message is going to be in bytes, maximum of 3 bytes is going to be present over there. Then the content, we can say that it may be equal to 0 or greater than 0 bytes. Depends upon the user, the information may be bytes of in content may be vary over there. So here the parameters which are associated with this message, these are listed. Already we have been seeing this content over there. I will show that content also over there. Okay. In generally, I am going to describe about the handshake action. So here the initial exchange needs to be established, a logical connection between the client and server. So how this exchange can be viewed, which is going to be viewed in 4 phases. Okay, that's going to be viewed in 4 phases. Let us see one by one, phase by phase. So first depends upon the time the client and the server both are going to be get establishing over there. And first one, which is going to be called as phase 1, establish security capabilities. Establish security capabilities. This is the first phase. This phase is used to initiate a logical connection and to establish the security capabilities that will be associated with it. The exchange is initiated by the client, which sends a client hello message. Client hello message with the parameter. What are the parameters are going to be present over there? In the sense, 3 parameters are going to get present over there. A version, yes, that's nothing but the hello message which consisting of including a protocol version, session ID, and a random number which is going to be present over there for the cyber shoot. So these are the things which is going to get present over. What do you mean by version over here? The highest SSL version understood by the client, that is going to be used over there as version. Already we have seen that version 3 we are going to use. Higher version, major version is 3, minor version is going to be 0. That we are going to use over there. And a random number. A client generated a random structure containing of a 32-bit timestamp and a 28-byte generated by a secure random generator number which have been generated by the random generator. These values serves as nouns and are used during the key exchange to prevent the replay attacks. That is the main purpose. We are going to use this random keys over here, random numbers. The next one is nothing but, the last one is nothing but session ID. Third one is going to be session ID. What actually the session ID is going to be there? A variable length session identifier. It's nothing but a variable length session identifier. It's a non-zero value which indicate that the client wishes to up to the parameter or update the parameter of an existing connection, or sometimes it may be to create a new connection on this session. Okay, a zero value which indicates that the client wishes to establish a new connection or a new session. Such a way it's going to be get present over there. Okay, next one, server allow. So during this time, what happens actually? After sending the client hello message, the client waits for the server hello message, which contains the same parameter as the client hello message. For the server hello message, we can say that the version field contains the lower of the version suggested by the client and the highest supported by the server. The random field is generated by the server and is independent of the client's random field. If the session ID field of the client was non-zero, the same value is going to be used by the server. Otherwise, the server session ID field contains the value for a new session. Okay, so the cipher suit field contains the single cipher suit which have been selected by the server from those proposed by the client. Okay, so the compression field, if you're going to see about that, which may contain the compression method which have been selected by the server from those proposed by the client. Always the client is going to propose, then the server is going to decide which has to be get used over there. Such a way it's going to be done this one. So the first element of the ciphersuit parameter is nothing but key exchange method. That is nothing but the means by which the cryptographic keys for conventional encryption and MAC are exchanged. Those things are going to be get present over there. In general, if you're going to see about that, a cipher suit is going to be used over there. This is nothing but the list which may contain the combinations of cryptographical algorithm supported by the client in decreasing order of the preference. Each element of this list, for example, which defines both a key exchange algorithm and a cipher specific protocol. Okay, and the compression method. This is nothing but the list of compression methods already which have been supported by the client. So meanwhile, the message protocol has some kind of thing that's nothing but hello request, client hello, server hello, and a certificate exchange or a server key exchange or certificate request. Such things are going to get present over there in this one. Such a way, it's going to do the establishing the security capabilities which is going to be get present in this particular phase 1. Okay, the next phase which is going to be called as server authentication and key exchange. Server authentication and key exchange. So before going to this server authentication and key exchange, and a few more data are going to be get present. That is nothing but a key exchange methods which are going to be supported by this client or requested by the client to the server. That is nothing but maybe an RSA algorithm or fixed Diffie-Hellman algorithm or imperial Diffie-Hellman algorithm or anonymous Diffie-Hellman algorithm. Such a way the algorithms are going to get used over there. And meanwhile, some of the key exchange methods which is going to be requested by the client in the cipher specific, which is going to be a cipher algorithm, maybe RC4, RC2, DES algorithm or triple DES algorithm or DES40, such algorithm etc. may be requested by the server client to the server. And for the MAC algorithm, it may be usually MD5, message digest 5 or SHA1. Okay, and for the cipher type, it may be stream cipher or a block cipher. That's going to get requested over there. And meanwhile, which is going to give an hash size, it may be 0,16 for MD5 or 20 for SHA1. Already we have come across over there in the last video itself. The key material which is going to be used over here is nothing but a sequence of byte that contains data which is used in generating the right keys, and the initialization vector size may be a block cipher cipher block chaining encryption. In the sense, we have to use an IV value which is going to be present over there. Then we are going to enter into the phase 2. It's nothing but server authentication and key exchange. Here the server begins with a phase by sending its certificate. if it needs to authenticate, it needs its certificate, so that the message contains